MH370 may never be found. Not because the searchers aren't trying, not because the technology doesn't exist, but because 7 specific conditions have aligned to make this the most difficult search in aviation history. What you are about to see is why the southern Indian Ocean seabed is more complex than the area where Air France 447 was recovered, how drift models can be scientifically accurate but still point to the wrong location, and why even advanced sonar technology has blind spots that could hide a debris field indefinitely. Air France 447 crashed in the Atlantic Ocean in 2009. Investigators knew the crash location within a 40 nautical miles radius. The aircraft sent automated maintenance messages before impact. These messages provided altitude, airspeed, and system failures. The search area was small and well-defined. It still took 2 years to find the wreckage. MH370 sent no distress call, no automated messages, no emergency locator transmitter signal. The only data comes from satellite handshake pings within Inmarsat. These pings created arcs showing possible aircraft positions at specific times. The 7th arc is the final position ring. But satellite data provides distance from the satellite, not precise location. The 7th arc is a line, not a point. It stretches thousands of kilometers across the southern Indian Ocean. And the crash location depends entirely on one assumption. Was the aircraft flying itself on autopilot when it ran out of fuel? Or was a pilot actively controlling it until the end? The ghost flight theory places the wreckage close to the 7th arc, a high-speed spiral descent, vertical impact. The controlled ditching theory places the wreckage up to 120 kilometers beyond the arc, a pilot gliding the aircraft after fuel exhaustion. That 120-kilometer difference is the gap between the search zones. 3 search operations focused on the ghost flight assumption. 229,000 square kilometers searched. Nothing found. If the controlled ditching theory is correct, every search has been looking in the wrong place, and we will not know which theory is correct until the wreckage is found. This is the first reason MH370 may never be located. We do not definitively know where to look. The search zone sits in the southern Indian Ocean. Water depth ranges from 4,000 to 6,000 meters. That is deeper than the Atlantic zone where Air France 447 was found. At 6,000 meters, the pressure is 600 times atmospheric pressure at sea level. Equipment operates at the edge of its design limits. The Hugin, 6,000 autonomous underwater vehicles used by Ocean Infinity, are rated to 6,000 meters. But operating at maximum depth reduces reliability. It increases the risk of equipment failure, and it limits the time each AVU can spend on the seabed before requiring recovery and maintenance. Deep water also means longer deployment and recovery times. An AVU takes hours to descend to 6,000 meters, hours to ascend. That time does not contribute to search coverage. It is dead time, and it reduces the total area that can be scanned per day. The deeper the water, the slower the search. The slower the search, the longer it takes to cover the target area. And the longer the operation, the higher the cost. Ocean Infinity operates on a no-find, no-fee contract. Every day at sea is an expense with no guaranteed return. Deep water makes this economically unsustainable over long periods. The southern Indian Ocean floor is not flat. It is geologically active, fractured by the southeast Indian Ridge. The seabed features deep canyons, seamounts rising thousands of meters, and abyssal plains broken by ridges and valleys. Sonar technology works by sending sound waves downward. The waves reflect off objects and return to the sensor. But complex terrain creates shadows, areas the sonar beam cannot reach. If a piece of wreckage sits in a canyon, or on the far side of a seamount, or in a crevasse, the sonar may not detect it. Ocean Infinity acknowledged, after the 2018 search, that terrain complexity may have caused some areas to be missed. The 2026 search used higher resolution Hugin AUVs specifically to address this. But even advanced sonar cannot eliminate all blind spots. The terrain itself may be hiding the wreckage, and if the debris field is small, if it's scattered into a canyon or settled in a crevasse, current technology might pass directly over it without detection. This is not a failure of the searchers. This is a limitation of physics. Debris from MH370 washed ashore on Reunion Island, Madagascar, Mozambique, South Africa, and Tanzania. Scientists at CSIRO and the University of Western Australia ran drift models. They used ocean current data, wind patterns, and known debris drift rates. They worked backward from where the debris was found to estimate where it came from. The models are scientifically sound, but they are based on assumptions. Assumption 1. The debris entered the water at a specific time. Assumption 2. The debris floated in a predictable way. Assumption 3. Ocean currents behaved as modeled. Any error in these assumptions changes the calculated origin point, and drift models provide probability zones, not precise coordinates. The CSIRO model identified a high probability area. Ocean Infinity searched it. Nothing was found. This does not mean the model is wrong. It means the model is probabilistic, not definitive. The wreckage could be in a lower probability area that was never searched, or the debris could have drifted in ways the model did not predict. Barnacle growth patterns, buoyancy changes over time, interaction with subsurface currents. These variables introduce uncertainty, and uncertainty means the drift models can point searchers to a zone, but they cannot guarantee the wreckage is there. Most aircraft crashes create a large debris field. High-speed impacts shatter the aircraft into thousands of pieces. The debris spreads across a wide area, making detection easier. More pieces mean more sonar targets. But if MH370 was ditched under control, the debris field could be much smaller. A controlled water landing keeps the aircraft more intact. The fuselage may have sunk in larger sections, resulting in fewer pieces. Smaller radar cross-section reduces sonar detection. If the aircraft ditched and sank relatively intact, the debris field might be concentrated in a small area, tens of meters across instead of kilometers. Sonar surveys operate by scanning long parallel tracks. If the debris field is small and the survey lines miss it by even a few hundred meters, the wreckage will not be detected. The probability of detection depends on debris field size. A large scattered field is easier to find. A small concentrated field is easier to miss. And we do not know which type of debris field we are looking for, because we do not know how the aircraft entered the water. MH370 disappeared, March 8, 2014. It has been on the ocean floor for 12 years. The southern Indian Ocean is not geologically stable. Sediment accumulates continuously. Volcanic activity, underwater landslides, biogenic material settling from above. Over 12 years, sediment can cover debris. If wreckage is partially or fully buried, sonar detection becomes significantly more difficult. Standard side scan. Sonar detects objects protruding from the seabed. It is less effective at detecting buried objects. Sub-bottom profilers can penetrate sediment, but they have lower resolution, and they are not standard equipment on all search AUVs. The longer the wreckage sits on the seabed, the more likely it is to become buried, and buried wreckage is exponentially harder to find. This is why time matters. Air France 447 was found 2 years after the crash. MH370 has been missing for 12 years. Every year increases the probability that sediment has obscured the debris. And if the wreckage is buried under even 1 meter of sediment, current search operations might pass directly over it without detection. Ocean Infinity operates under a no-find, no-fee contract. $70 million if the wreckage is found, 0 if it is not. This contract structure incentivizes results, but it also creates limits. Ocean Infinity is a private company. Every day, The search vessel operates, costs money. Fuel, crew salaries, equipment maintenance, AUV operations. These costs accumulate even when nothing is found. The company can only sustain unpaid operations for so long before it becomes financially unviable. Phase 3 searched 7,236 square kilometers, 48% of the planned 15,000 square kilometer target. The vessel departed for Samoa on February 4th, 2026. 25 days of contract time remain, but the Southern Indian Ocean weather window closes in April. If Ocean Infinity does not return before then, the search will pause until late 2026 or 2027. And with each pause, the political and public will to continue diminishes. 12 years have passed. Families still demand answers, but governments have limited budgets. Public attention fades. Without sustained political pressure and financial commitment, the search becomes a lower priority, and eventually it may stop entirely. Not because the wreckage cannot be found, but because the resources and will to continue searching run out. 7 reasons: search zone uncertainty, extreme ocean depth, seabed terrain complexity, drift model limitations, potentially small debris field, sediment coverage, and financial and political will. Individually, each reason is an obstacle. Together, they create a convergence of conditions that make MH370 uniquely difficult to find. Air France 447 faced 1 or 2 of these challenges. MH370 faces all 7 simultaneously. This does not mean the wreckage will never be found. It means the probability decreases with each passing year. The search zone may be wrong. The debris may be hidden in terrain. The drift models may have pointed to the wrong location. The debris field may be too small to detect. Sediment may have buried it, and the financial and political commitment may eventually run out. Ocean Infinity has 25 days of contract time remaining. The technology exists to find the wreckage if it is in the search zone. But if it is not, if the controlled ditching theory is correct and the wreckage is 120 kilometers beyond where anyone has searched, or if it is buried under sediment in a sonar shadow on a complex seabed, then the wreckage of MH370 may remain on the ocean floor indefinitely. Not because we stopped trying, but because 7 specific conditions aligned to make this the hardest search in aviation history. And sometimes, even the best technology and the most determined effort are not enough. Let me know your thoughts below. If Ocean Infinity returns to the search zone, you will know immediately. Subscribe for updates, because 239 families deserve answers, even if finding them may take longer than any of us hoped.